Hello everyone, here Alberatz. For more than 300,000 years, humans have lived on a majestic planet called Earth. Over time, humanity evolves day by day on Earth. However, this evolution is not necessarily positive. In fact, we have contributed to a huge increase in greenhouse gases in the Earth's atmosphere. There is a decrease in Arctic sea ice due to climate and weather changes. Also, the average temperature of the Earth is increasing more and more while causing drought. In addition, there is the accumulation of plastic in the ocean which causes a loss of biodiversity, including the ingestion of plastics by animals which cause them lacerations, internal injuries and death. Human-induced deforestation increases the risk of epidemics and infectious diseases from animals and insects. Finally, there is the increase in radiation which increases the risk of cancer. In addition, the population on Earth continues to increase exponentially. For example, in 1950, there were 2.5 billion humans on Earth, or 31% of the current population, while in 1990, there were 5.3 billion humans, in other words, 66% of the current population. In short, the population increases at the same time global warming, which is very problematic for our planet. However, if we are unable to preserve our planet in good health, then it is necessary a solution as soon as possible in order to avoid a catastrophe. Well, there is a solution. This solution may seem impractical or even absurd to some. This solution is spatial colonization. This solution consists of a permanent and largely self-sufficient human habitation outside the Earth. However, in order to be able to colonize a planet, for example, it is absolutely necessary for man to be able to meet the conditions required for life of the terrestrial type. So which planet among the 7 located in our solar system, in other words Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, can it accommodate humans according to its atmosphere, its temperature and possibly its biosphere? To begin with, the Jovian planets, in other words the gas giant planets of our solar system like Jupiter, Saturn, Uranus, and Neptune cannot be considered as a habitable planet, since they do not have a solid surface. Now, for the remaining 3 planets, Mercury cannot be considered a habitable zone for 2 main reasons. First of all, Mercury has a diameter of only 4,880 kilometers, which is far too small. This diameter represents 38% that of the Earth. Also, its proximity to the Sun means that the temperature is too high to be able to support life. Concerning Venus, it cannot be considered as a habitable zone since there is like hell. Certainly, there are sulfuric acid rains that can cause serious burns when it comes into contact with the skin. Also, just like Mercury, its temperature is very high for humans. Finally, we arrived with the last remaining planet, Mars. Mars is the 4th planet in the solar system with a distance of 1.38 astronomical units from the Sun. In its atmosphere, it is mainly composed of CO2, in other words carbon dioxide. Also, its diameter is 6,805 kilometers, or about half that of the Earth. Mars is a telluric planet, in other words a planet mainly composed of rocks and metals. This type of planet has a relatively high density, slow rotation, a solid surface and has no rings. Also, a Martian day lasts 23 hours and 20 minutes, in other words 40 minutes less than an Earth day. The red planet has 2 moons, Phobos and Deimos. These moons are extremely small compared to our moon with a diameter of 22.2 kilometers for Phobos and 12.4 kilometers for Deimos. Back to the subject. Today, can we colonize Mars in order to potentially avoid a catastrophe on Earth? At the moment, no, because the current properties of Mars are not preferable to a habitable zone for humans. First, because Mars has no global magnetic field. Before, Mars had a magnetic field allowing the maintenance of a dense atmosphere. On the other hand, it lost its magnetic field after its outer core gradually cooled to the point that the dynamo effect generating the planet's magnetic field disappeared. The magnetic field is very important. Indeed, on Earth, for example, it protects us from interplanetary space, in particular from the solar wind, which would break the very structure of our DNA and erode the atmosphere. In addition, according to the American Institute of Medicine, there are between 20 to 30 short to long-term health risks if we are going to Mars. For example, there is the vision disorders, bone demineralization, muscle loss, and cancer. Atmospherically, Mars is only composed of 0.13% oxygen. For comparison, the Earth is made up of 21% oxygen, or 20.87% more. This very small amount of oxygen comes from the fact that the Martian atmosphere is about 100 times thinner than Earth's. Thus, man will not be able to carry out cellular respiration on Mars. In addition, it will be necessary to make a round trip between Earth and Mars, two planets separated by 225 million km on average. To reach Mars, it will take about 228 and 333 days, which is extremely long. Finally, the atmospheric pressure on Mars is 3 times lower than that on Earth, and this poses many problems. First of all, liquid water cannot exist on the surface. If, for example, we install water on Mars, the water will boil at an ambient temperature of 0°C because of the low atmospheric pressure. In addition, the H2O partial pressure is less than 6.1 millibars. However, the maximum partial pressures for water do not reach 0.66 millibars. Water can therefore only exist in the form of vapor or ice on Mars. All these obstacles make the mission to colonize Mars impossible. So what should we do? Well, there is a way to colonize Mars another way. This solution is very optimistic and far from being feasible. When we first talked about it, people thought of a classic science fiction theme. For them, it was a completely absurd and unimaginable subject. Simply too dreamy a subject. However, it is necessary to make the impossible possible if it is a question of a world which risks collapsing. That solution, ladies and gentlemen, is the terraforming of Mars. What is terraforming? Terraforming is a hypothetical process, that is to say that we modify the climate, the surface, the atmosphere, and the current properties of Mars. By modifying them, we seek to make the planet habitable for humans and all other forms of terrestrial life. First, we must completely rebuild the atmosphere. For this, there are several possible options. Concerning the atmospheric pressure, we can release the dioxide, this carbon stored in great quantities in the ices of the poles and the rocks. Then this gas will be able to effectively trap heat. This will increase the pressure and temperature of the Martian atmosphere. Also, in order to better conserve the heat received, the albedo coefficient, that is to say its ability to reflect light from its surface, must be reduced. Now we know that Martian soil contains nitrogen, an essential nutrient for plants. So plant growth is not a problem. Thus, we plan to plant plants on Mars in order to carry out photosynthesis, a chemical reaction using the energy of light to combine water, H2O, and carbon dioxide, CO2. This reaction produces simple carbohydrates and oxygen, O2. In addition, there is also the NASA Perseverance rover which contributes to the production of oxygen in the atmosphere of Mars. Effectively, Perseverance uses electricity and chemistry to split CO2 molecules, thus producing oxygen on one side and carbon monoxide on the other. However, the tool was developed to be able to generate up to 10 grams of oxygen per hour, which is extremely low. On the other hand, in order to increase the temperature, it suffices to increase the amount of greenhouse effect to give impetus to the process. You should know that the greenhouse gas traps heat in the atmosphere, which increases the temperature. This is precisely what is happening on Earth with global warming. To achieve this, we will send a rocket to crash on Mars. Yes, you heard that right. A rocket containing CFCs, a very potent greenhouse gas, will crash into Martian soil to release the gas for planetary changes to take place. Now, for the magnetic field, scientists rely on Phobos. By creating a kind of plasma torus from the particles on Phobos by ionizing and then accelerating, it will create a sufficiently strong magnetic field. Or we can place at the Lagrange point, the point in space where the gravity fields of two bodies in orbital motion around each other provide exactly the centripetal force between the Mars-Sun system in order to have a magnetic dipole that produces a magnetic field. To conclude with the terraforming of Mars, I think the idea of going there will avoid a potential catastrophe. Of course, I wish that we, humans, could weld together in order to fight the problems that our planet Earth endures. Unfortunately, man's ignorance of climate change is very real. So we have to consider solutions like the terraforming of Mars. Let's enjoy this wonderful planet that is Earth, because finding one like this would be almost impossible. Thank you for watching the video. Don't hesitate to subscribe to encourage me on YouTube, and also to click on the like button, which is obviously very appreciated. Until next time, dear astronauts.